So, hi everyone. Today I'm going to make a brief status update about the VKMS. I mean, there's like 2 years that we don't talk about VKMS here at XDC, and a lot has changed in VKMS since then. So let's make a small recap and talk about the news at VKMS. So what is VKMS? VKMS stands for Virtual Kernel Mode Setting. It's a software-only model of a KMS driver, which basically means that you can emulate a KMS driver using software. It's very useful when we want to test an application and compositor, and we don't have the hardware needed. We are on a headless machine. VKMS is a community project, so all the maintainers are volunteer, and we are really thankful for everyone that contributes to VKMS, and is GPU vendor agnostic, which means that we really rely on the DRM API, not in any specific GPU vendor stuff. So the first thing that really changed in VKMS recently was the performance. We had like a huge performance improvement in the couple of months. Performance was a major problem in VKMS because you need to make the composition and the blending on software, which can be quite slow. So we were able to improve the performance in about 30%, which is awesome because now all planes are blended at once, and we make the blend calculus per line instead of per pixel, which was a major update. Also, we had a memory consumption update because we used to need the whole image at once, which means that we needed a buffer from width and height. And now we only need 2 lines with size of a width, which means a memory consumption of 2 width. And this also means that we have like less IGT timeouts because due to the performance, we had like plenty of IGT timeouts, and now they are pretty rare. So this is really awesome. So thanks Igor and Pekka for working on this nice feature to VKMS. And about the composition used to be executed on top of the primary plane, which means that the primary plane needed to be enabled, needed to be visible, and needed to be the same size of the CRTC, which doesn't allow us for many flexibility. So now the composition is performed on top of a black background with the size of the CRTC, which means that now the primary plane can be positioned anywhere, can be disabled. I mean, you can even make the primary plane not visible. This means that now we have more IGT tests passing, which is really important for VKMS, because there are a couple of IGT tests that demands the primary plane to be positioned. Also, now we have a full alpha blending on all planes because we used to use the primary plane for composition, so we couldn't make full alpha blend on the primary plane, and now we can because we are doing the composition on top of the CRTC. And we have brand new features as well. First, multiple overlay planes. We used to support only 1 overlay plane, and now we support up to 8 overlay planes, which is great. So thanks, Jose, for this feature, adding this feature in VKMS. And now we have support for 5 formats. We used to have support for only 2 formats because formats were really attached to the composition and blending, like the code was really mixed together. And Igor worked in decoupling those 2 features. And now, in order to add a new format to VKMS, you need only to add a function, which is great because it's much easier. You can only focus on the logic that you need for that format. You don't need to, think about changing the composition and blending. And we also had new features, such as plane rotation. It was one of the first plane features that we support. Now we support all rotations and reflections in our planes. And we had support for 1D gamma LUT with interpolation for each color channel. So thanks, Arthur, for working on such a nice feature. And we have more IGT tests passing. Those features have IGT tests, and now they are passing, which is great.
Hi, Melissa. We also have some issues that we are working on. It's still ongoing. We, after introducing all these new composition features on VKMS, some existing synchronization issues blew up. VBlank, for example, we have in VKMS simulated VBlank. And then there is a deadlock between the event lock and the timer, because that is, how can I say, intrinsic in the current simulated VBlank design. There is also a race condition between flushing the work queue and destroying the CRTC state. What we need to do, we already have an idea that we need to prevent a new job to be queuing up in the time interval. And there is another thing in VKMS by design that is a dependence across the VBlank, blending, and CRTC computation. So we need to work on keeping their pace of all these three steps synchronized. And for this, we need to ensure that whenever the VBlank tick enables a composition, then we will add a composed job to the work queue, and then ensure that the CRC computation will happen. So we also started to work on support other blend modes, pixel blend modes. We support the default DRM mode, pixel blend mode, that is the pre-multiplied, but we are working on other properties, other blend mode properties. And we are currently evaluate again the virtual hardware support to get rid of the simulated VBlank dependence. And finally, R2 is working on the NV12 multi-planar format. So many people in the DRI community have been contributed to VKMS. First, we can clap hands to Marius, Brandon, and Jim that sent a proposal to support multiple CRTCs, but also a way to use config.fs to set up plain CRC and composer. Alan is making the DRM developers' dream come true with the DRM CI, and she included the VKMS driver in the proposal. And finally, Harry worked on a GPU agnostic implementation of our new generic KMS caller API for the DRM KMS framework. So if you want to contribute to VKMS, you can find many ideas in the kernel of the official kernel documentation. Besides that, there are some interesting new things to do on VKMS that might be a good fit for small projects. One of them is adding unit tests for the composition procedure, composition steps. And another is fixing all failing tests on IGT that was detected by the DRM CI proposed by Ellen. Another thing that we have been discussing in the community is to kind of require VKMS support for new APIs and the generic APIs in the DRM KMS framework. But yesterday we just discussed about it, and right now it doesn't a good idea, because it isn't a good idea because we have also that performance issues and sync issues to treat on VKMS. And going deep on VKMS, implementing everything that the GPU is able to do, is capable to do, would be quite a lot of effort in software level. So, but we believe that VKMS is still a good way to validate and test new features in the DRM KMS framework. And yeah, I already talked about it, but if you want to contribute, you can get in start in the VKMS, checking the driver documentation that you'll find how to set up and playing with the driver. Yeah, we not only new features, but we also need more reviewers because I think the diversity of point of views is the key for building good solutions for not only for VKMS, but also for the DRM KMS framework. That is the proposal of the virtual driver. And as there is a close relation between VKMS and IDT, one can benefit from the improvements that we do in the other. So it makes sense to increase the coverage of IDT test and improving the whole DRM KMS framework validation. And is it? Yeah? Thank you for all the contributors in this time that 2 years ago that we are not doing a status update for VKMS. And yeah, questions? Yeah.
So for someone who's not too involved in the graphics world, can you give some examples of where VKMS is being used that you know of?
I know Weston is using VKMS, and as VKMS has a write-back connector, we can use it in a headless machine to validate things. Another usage would be for AI GPUs that we need a way to assess logging and things like that, and we need KMS drivers, but we don't have the head and the driver, the monitor, display way, so we can pass on through it using VKMS, and yeah, and also to validate the helpers and the functions on the DRM KMS framework in general, without the need, one thing is that it's a GPU agnostic way to validate it, so it's not. And another thing that was proposed by Harry is to validate the color features, the mathematical function work of that, but not necessarily how the GPU process the color transformation. It's, yeah, some examples I can mention. Okay, thank you.